All right, this is a video made for dual enrollment biology, Brandon Valley High School, and it's a combination introduction to Google Sheets and how that can be used and how that should be used, I think, to make your graphs that you'll be putting in lab reports and lab presentations, and also how to do a little bit of the basic data functions like standard error and standard deviation. So this is going to be a mock-up of what we're going to be doing for one of our first labs, which is measuring the effect of some thyroxine on tadpole metamorphosis. And one of the things that will happen as a tadpole morphs into a frog, it's actually going to absorb the tail, and those nutrients, those atoms are going to be used elsewhere, and you're going to see the tail actually shrink, which is a sign that the frog is actually going, that the tadpole is moving towards being a frog. So here's what I've set up. Let's assume we've been taking our data for 5 weeks. So I start at week 0 because no time has passed, and this is the day we begin. These are the readings we take. And I'm going to look at tail length, and I'm going to assume that this is going to be done by 3 different lab groups. So if 3 lab groups are measuring the same sample of tadpoles and they're going to record the tail length, or it could be even measuring the same tadpole, we can end up doing a little bit of data on it, which is that standard error and standard deviation. And it's standard error that we ultimately would like to include on the ideal graph. Not in every lab, but when it's possible, we'd like to include that in our graphs. So what I have is a tail length listed up there. If you don't know how to use these, if you want this repeated, you can just highlight the cell and get that in the lower right hand corner. And then if I want to include all of this data in my ultimate graph, most lab reports, you're going to want to insert the graph. That's highly visual. It doesn't take as long, as highly effective. Sometimes you will include data tables in the results and data section of your lab report, but usually this will go in your lab journal, but the actual lab report will be filled with something like graphs that will represent that. So do keep that in mind. I might want to go up here and label, this is team 1, and this one up here is going to be from lab group 3. Always good, if it's not in your lab notebook, if this is going to serve as the lab notebook, I would certainly add this. You don't want to end up a couple of weeks later putting together your lab report and you don't know what data you had. But let's assume we have something like this. So the first thing I want to do is I want to figure out what's the average. So what I'm going to do is highlight the cell where I want that to go, and on this or Excel, we always put in equals. And then what I would do is start typing up the function that you want to use. Sometimes the words don't match up, and sometimes that function isn't available on it. But so this first one, what are you going to do? Put in mean or average? I'd try them both. I happen to know average is the one that's going to show up. So I just hit average, and then once I get the parentheses, I can take the 3 that I want to average, and I'm going to either add another parentheses there, or I'm just going to hit return. So that one, every single reading was 56, so I expected that to be the average. I don't expect that to be the case for the other ones. So again, highlight that cell which has the function added to it. Going to highlight the lower right-hand corner and just drag that down. And I want to double check. This one, for example, I know it went up by 2 on reading 1, came back to 34, and this one went down, so that one makes sense. The other ones, I can tell that the function has been correctly utilized in this graph, that it is taking the average. It is not cheating at all to use calculators or something like pages to end up coming up with something like your data points. You need to know how to use the equation. We will take some quizzes in class where you're going to be given like 5 numbers. You're not going to be stressed on doing the math, and you'll be given the equation, but you will know how to manipulate it. You should know what things will influence these. But on this one, there's nothing wrong with using this to come up with the first number we need, which is going to be standard deviation. So what I'm going to do is I am going to, again, hit equals, And then I'm going to type that in. Again, standard deviation, I know it shows up. And I am going to, again, highlight these three. And I've highlighted those. You can see I have the correct range there. I'm going to hit return. I expected no standard deviation because there is no change, no deviation from the mean. But as I go along and highlight these other ones, as I said, these should all have some standard deviation. And there we go. This one is exactly what you would expect. We did 3 readings and they were all off by 2, meaning that is the standard deviation. So I've calculated the standard deviation there. Now I need to come up with the standard error. If you remember the equation, that is going to be standard deviation divided by the square root of n, which is your sample size. Since here, I'm going to start with this one. Well, let me start down here. With 2, since 2 is the standard deviation from these 3 readings, obviously my sample size is the number of readings I took, which is 3. But on this one, when you hit equals and start putting in standard error, you're not going to get a match for it. So there's different ways of doing this in terms of statistics. The one we are going to use is just the standard deviation divided by the square root of the sample size, n. Since all of these have a sample size of 3, the square root of 3 is about 1.7. What I'm going to do is I am going to say equals, click this number, a divide, and I'm just going to put in a 1.7. Hit return. So that's my standard error. I go up, and now I have this. Might as well label it. And this one up here is going to be standard deviation. Now I've got to decide what things I'm going to put in my graph. And there's going to be a problem. I cannot go and delete these. I'm not going to put all of this data on my graph. What I really want is the average for all the readings, and I want to use these to add some error bars. But if I delete these here, the average will go away because those are then going to be gone. So there's a number of ways to do this, but I'm just going to hide those. And you'll notice that doesn't change the readings. I haven't deleted them, gotten rid of them. So what I'm going to do here is now I have the week and the average. I'm going to highlight that region and go over here to insert chart. Just a heads up, do not stop right here. I never like it when you kind of do the minimum. But at least I see it is going down over the weeks. This looks fine. I could do a bar chart or a line graph. But what I want to do is get into some of the details here. So go into this edit the chart, and I come over here. And one of the first things I want to do is notice how these are all the same color. That will not work if you're doing error bars. So there are ways of setting it up, but when I get the question, what I really recommend is click on some of these. And if I can get those to be different colors, I can change all of this later on in my graphing, but this is going to allow me to add error bars for each. So now when I go over here to customize, now that I have that done, I am going to be able to do this. So here it says apply to all series. If I end up doing that, I can put in error bars, but this is not going to work to accurately show standard error because not every reading had the same standard error. If you remember at week 0, they all agreed at 56. It shouldn't have an error bar. That tells us that 3 different groups got the same reading. There's a higher confidence in the accuracy of that reading. So on this one, I do not want to do that for every group. So if I go here to the first one, it's blue. I'm going to say error bar. I do not want percent. The way we use our calculation, it's a raw number. And for this particular reason, I can look over here and my standard error is 0. Now what I want to do is go over and do that again, but let me go to week 1. And on week 1, my standard error was 0.3. So I am going to again do that. I'm going to add error bars, and I'm going to add a 0.3. And week 2, let's go on to week 2. And those off. Made a mistake here. I'm going to have to correct. All right, I had made an error there. What I want to do is go over here to where it says series, and I had made a mistake. I had started off applying to all the series. So now let's go and correct this. So for let's go back to week 3. I'm over here. My standard error there is going to be 0.6. So it's a constant, but it's now 0.6. And yeah, I could add a data line. That's always a good idea. Since I made mistakes on the earlier one, if you recall from week 3, my standard error was 0. Could add that in there. And then go on to week 1, making a correction for where I made a mistake, and that one is going to be week 0.3. Now I still have to go to week 4, and if you look over there, week 4 was my largest. At 1.4. Add those. I want the data line in there. Let's go up to week 5, and this is where I'll add my 1.2. Okay, so I'd want to touch that up a little more, but you can see there that we've gotten a graph, basic graph. Before I turn it in, I'd do a little more touch up, but notice that not all the error bars are the same size because they shouldn't be. They weren't all the same reading. So that's how to add error bars into a basic graph.